Welcome to the HBM Test and Measurement FAQ video series. Hi, I'm Clark Anderson, HBM Applications Engineer, and in this video I'm going to provide an overview of setting up computations in catmanEasy. Once you are connected to your device with catmanEasy, the computations are found on the DAC Channels tab in the top ribbon. The computations window will pop up, and the first tab is for the algebra and formula calculations. This computes channels in sample rate timing. You can use channel names, numbers, operators, and functions in the formula. All channels used in a formula must belong to the same sample rate group. You just drag a channel from the channel list onto the formula or specify the channel name manually in the formula. Here is a computation for a torque measurement. The force sensor is mounted on a half-meter lever arm. Therefore, the torque measured is the force times the moment arm with resulting units of Newton meters. The computation channel is given the name torque. After you click the Create Computation button, the computation channel is populated to the channel list on the left. The Algebra and Formula tab also have built-in functions. Here the function max is selected from the statistics group. The computation is given the name force max, and the computation will find the max value for the U9B force sensor. When you create visualizations, the computation channels can be used just like the hardware channels. Here I have the U9B force sensor, the torque computation, and the force max computation. When you run the test, the computations are calculated in real time and displayed with the hardware channels. The second tab of the computations window is for strain gauge stress analysis. If you are using rosette strain gauges, this is where you can create the real-time rosette calculations. Here you can see for the strain channels, I have assigned strain 1, strain 2, and strain 3 from our hardware channels. I have selected to create the computation channels of angle, principal nominal stress 1 and 2, shear stress, reference stress, stress X and Y, the principal strains 1 and 2, and strain XY, and shear strain. I select the type of rosette, in this case it's a 4590, enter the material properties, and then click Create Computation, and here the name rosette was given to the computation channels, so you'll see on the left we have rosette underscore SNA, etc. for all the calculations. The next tab on the computations is the filter computations. This function group makes different computations for smoothing, filtering, phase correction, and computation of RMS available. Drag a channel from the channel list onto the input channels of the computation, or you can assign the selected channel via the selection button. You repeat this operation to create several computation channels simultaneously. Here the U9B force sensor is used to create a mean value computation. The computation channel is given the name force mean. The next computation tab is peak valley computation. This computation inspects load cycles in a signal. Several computation channels will be created, minimum, max, and cycle counter. Peak valley detection is done automatically, taking hysteresis into account. Here are the computation channels created when using peak valley. The name you give to the computation will be used along with max, min, and counts. The next computation is the class counting. This will compute rain flows, time at level span pairs, and two-dimensional time at level histograms. For For the rainflow, this class counting method is used in the determination of material fatigue. The time at level class computation method determines how long a signal is located in a certain amplitude range. And the two-dimensional time at level counting method also involves determining how long a signal is located in a certain amplitude range. The next computation tab is for the math libraries. You use this tab to select custom-made real-time computations which are performed together with the standard Catman real-time computations. Requirements for this are that the DLL performing the computation must be created. The DLL has to be copied into the drivers folder in Catman's installation folder, and the file mathlib.inf must be created or modified. This file in the directory's drivers must have an entry describing the DLL. The next computation tab is for electric power computations. This creates all the necessary computation channels for the measurement of electric power, RMS for current and voltage, active power, apparent power, reactive power, power factor. Only voltage and current channel are necessary as input. You just drag a channel from the channel list onto the input channels of the computation or assign the selected channel via the selection button. The last tab is the signal generator computation. This allows you to create simulated measurement values to prepare a DAC project when you do not have access to real hardware signals. With a playback file, you can replay already measured data. The time base of the signal is more precise if a hardware channel is sampled in the sample rate group. In this example, a sine wave is created with a frequency of 1 Hz and a max min of 10 volts and negative 10 volts. Here's the sine wave that was created with the signal generator computation. The online catmanEasy help contains additional information on the computation channels. Thanks for watching, and if you have any questions, please feel free to call, email, or visit our website for the latest product solutions and downloads at www.hbm.com.